Alrighty, we're good to go. So we're going to talk about kind of like what Prometheus is, how it's used in Kubernetes, and try and give you guys an idea of how you can get started with it and where you can kind of go um, using other tools like Grafana and AlertManager. So this is sort of the agenda of the 20-minute talk or so. I'm going to give you a quick overview of what Prometheus is. We're going to talk about time series and what that really means. We're going to talk about how it scrapes endpoints to gather its information. Then we're going to talk about things like how it's used in Kubernetes, some of the various different ways you can deploy it and how it detects objects, as well as sort of going into Alert Manager and Grafana, like I talked about, and how we can use the data that we gather with Prometheus to sort of visualize and alert off of that data. And we're going to do a quick little demo at the end. So I guess throughout the whole presentation, I'll probably reference various things throughout the actual code as well anyways. So I guess let's kind of start with like what Prometheus is. It's a time series database that's open source. It basically uses this whole concept of pulling HTTP endpoints from different applications and services to store them in a method that allows for flexible and real-time querying and alerting. It was developed back in 2012 by SoundCloud, and I guess eventually went on to be, it was open source from the get-go and was eventually handed over to the Cloud Native Computing Foundation over in 2016. So it's been around for a long time. I've been using it since probably 2017. There hasn't been like an overwhelmingly dramatic amount of changes since then. It's really, people have been building out how to easily instrument Prometheus, as well as sort of simplifying and abstracting some of those processes out. At least that's from my experience. I haven't seen anything dramatic change with it, Prometheus itself. So this overwhelming chart here is sort of a high-level overview of like how a Prometheus architecture works. In the center here, we have our Prometheus server. So basically, the Prometheus server itself is just like think of it as this application that's pulling these different endpoints and storing that data in a time series database. It is also used to query that information. So one of the first things we do with a Prometheus server is try to discover what applications we want to hit. And I'll show an example of that later on. But basically, it's doing service discover to find out what we want, what endpoints we want to hit. And Prometheus then goes out, sends a HTTP request to those applications. We'll see what that data looks like in a little bit. It gathers that information, brings it back to the Prometheus server, stores it in that time series database, and allows for us to do a lot of the other work that we want to do later, like visualizing it in Grafana, or we can actually send that data off to Alert Manager. And I guess, when I show these examples, it'll kind of all come together. But I guess just know that Prometheus is, rather than you sending data directly to it, like let's say InfluxDB or SQL or other databases, it usually operates in the manner where it pulls out. You tell it where to reach, it reaches out and grabs that information on a cadence. So I guess that's another thing. Like it can reach out every 30 seconds, every minute. That kind of stuff is configurable. In Kubernetes by default, I believe it's like every minute for some endpoints and 30 seconds for others. But and yeah, just I also want to take the opportunity to say that like Alert Manager, which we'll talk about later, has the ability to send all of these alerts to things like PagerDuty, Slack, direct email, stuff like that. So why time series? I mentioned before that Prometheus is a time series database. A lot of people compare it to, what's the other one that's at the tip of my tongue? I can't think of it right now, but another big one is InfluxDB. Time series is very valuable because it's optimized to store this data in a very lightweight fashion. So, when you think of a MongoDB database, it's got this object, there's a lot of information in there. When you query that data over a long period of time, it gets very exhaustive, the search queries. And storing very little bits of values and key value pairs allows you to easily query these values over very large and expansive periods of time very quickly. And you'll kind of get an example and see it as we go on. But that's the gist of it. As I mentioned before, Prometheus is reaching out and scraping endpoints. And actually, after this slide, I'm going to go and show you an example of one. But how it works is all of these different applications, they use a library or some other tool or application to basically render and present this like /metrics endpoint. So for instance, things like Kafka, MongoDB, Python applications, what you can do is you can either stand up this agent alongside your service like Kafka, for instance. You would stand up a service alongside it that allows you to access Kafka information, things like topic usage, network in and out. Meanwhile, with programming languages, you can actually use one of the many open source libraries to get information on, endpoint usage, different activities, and you can create custom metrics as well. Excuse the sirens there. I'm gonna mute myself real quick. There we go. All right. And there's another one. So this is an example below of what a time series metric looks like. And we'll go ahead and take not a time series metric, what a metric and a Prometheus endpoint looks like. And we'll go see what it looks like on a large page here. But the whole idea is that we provide the Prometheus server with a list of actual domains and endpoints to hit. This is an example we have here of like an external scrape config for a bunch of Kafka servers. So if our Kafkas had Prometheus endpoint up, and these were our addresses here, I could basically tell my Prometheus to go ahead and scrape those by just providing the names of the servers along with the path. If there's any port differences, we can specify that. And later we'll also talk about sort of auto discovery too. So sometimes you don't even have to go this far. But the point, and I think the popularity around Prometheus is the fact that there's support for so many different things, which you can find on prometheus.com or .io, I believe it is. But you can also create your own. And so with that, I want to show an example of basically what these endpoints look like. So I've gone ahead and created a very, very simple Python Flask application. So it's just a handful of API endpoints. And I created a Prometheus endpoint using the library for Flask. And this is the information that Prometheus is scraping off of Kubernetes nodes, Kafka exporters, all these different tools and programming languages. Their Prometheus endpoints look very similar. It's line items for each one of our metrics where we have a metric name. In this case, it's Flask _HTTP. I'm not gonna read the whole thing there. And then we have this key value right here. And I'm sorry it's so tiny, but we can see when we go back to the slideshow where it looks like blown up. And we have this key value pair that we can filter off of and sort of visualize in different ways. And then we have the value at the very end. In this case, this is just a very large value, and we'll start to see when we make queries how this all works. But every minute Prometheus is hitting this endpoint, gathering this information and storing it in the database. So to actually query this information, they use a query language called PromQL. We're going to kind of see some examples of it as well. The big thing that I want to kind of try and articulate is that it has functions to take this data and present it over time. So for instance, this is a metric right here, HTTP _request total. And we want to see the metrics for the get method on the status endpoint. We can go ahead and find out what the rate of change is by saying this 1 minute index here, which means like over the span of 1 minute, give me the rate. And so that would allow us to visualize exactly that, the rate of change, to get things like, has this endpoint been hit 10 times over the last minute? So it takes the current value, subtracts the one from a minute ago, and presents that. And we can also go ahead and sum that up by path. And actually, in retrospect, this is a little messed up because I actually specify the path here, so it doesn't really matter. But there's a lot you can do with PromQL, and that almost could have its own example of, its own little presentation, to be honest. So I want to go back to that Python app that I had up here. So I have a handful of endpoints. Some like reach out to a RabbitMQ server, some go to Postgres. In fact, I actually have 2 endpoints. One waits 1 second and one waits 5 seconds. You're probably wondering, why the hell would I do that? I'll kind of show you. So I'm going to go ahead and run a pretty lightweight load test against my application. And so this is the metrics endpoint for it. If I refresh this page, we're going to see a lot more content here. So I'm going to go ahead and refresh, and all of a sudden we see a lot of data here. In fact, each one of these blocks is what's called a histogram, which, if you see, almost all these metrics are identical with the exception of this LE equals. This is basically just allowing us to get an understanding of distribution of time and how long these requests actually take. But I really, that sort of gets a little bit more in depth with what histograms are. That's not really the big focus here, but basically every time I update this endpoint, it updates very immediately. The thing is, Prometheus is only scraping it every minute. So it's only going to be able to tell the difference, on a less frequent cadence. In fact, I think actually I have it configured to run every 30 seconds. So let me just go back to the slide real quick, actually, but let me see. So that's kind of what's going on with this Python Flask application. As I mentioned before, this can be used with all these different tools like RabbitMQ, SQL to expose those metrics. So I then kind of want to segue into why Prometheus is popular with Kubernetes and how a lot of people are deploying it. So this is a chart that I took offline. It's a little messy, but basically the idea is that the Prometheus server is talking to the Kubernetes API. And with that, it could find out any new pods that have come up, any new nodes that are online, things like the kube state metrics. And it will then talk directly to those nodes. And on each one of these Kubernetes nodes, basically you added a replica set where a actual container is spun up on each one of these nodes that it reaches out to and scrapes to get things like the actual containers on those nodes, the node's CPU, memory, network in and out, and things like that. And again, we kind of visualize that we can have Grafana, which reaches to the Prometheus server to visualize it. And we can also send these things out to AlertManager. And so how you go about deploying Prometheus in Kubernetes can sort of vary, but I would say easily the most popular way is using Helm. So Helm is just a package manager for different tools in Kubernetes. It makes it very simple where you can just have one YAML file that you edit rather than having to do all these things. And with Kubernetes, there's a lot of people working on it in this space. So Helm allows, or at least the public Helm repos, allows for a lot of easy reusability. So the actual Prometheus Helm chart itself is widely used. Additionally, there's also the Prometheus operator Helm chart. So the Prometheus operator is very similar. In fact, it actually uses the Prometheus Helm chart, but also uses what's called custom resource definitions. So what that means is in Kubernetes, we create these new special objects just for the purpose of Prometheus. And we'll kind of see that in a little bit. So how basically we discover what applications we can scrape in our Kubernetes cluster can vary. Inherently, almost all the applications use what's called service monitors, which I'm not going to really go into detail about because they kind of look ugly. And a lot of it's just out of the box and they can kind of graze over it. But basically what it is, this is an object that our Prometheus server is constantly looking for. So anytime we add a new service monitor, our Prometheus server says, okay, cool, I'm going to scrape that endpoint. And what we can do is we can make it very simple for developers to scrape their pods by adding a custom scrape config like this one right here. And I know this looks kind of messy, but it's pretty much taken right off of GitHub. And to scrape the Prometheus endpoint in a new container, all you have to do is add these 3 annotations to your pod, and the Prometheus server will automatically pick it up, start scraping it, and go on from there. So I know with my dev team, basically what we've done is exactly this. So now if a developer wants to be able to get application-specific metrics, all they do is they add a Prometheus operator to their application, or a Prometheus endpoint rather, either using a library or some other method. And then they just add these 3 annotations and the rest is all taken care of for them as far as gathering that metrics. And now we're kind of going into the more exciting parts, I think, of how do we visualize all this data that we're gathering? What do we do with it? And so this is an example, and I'm actually going to take you to my Kubernetes or my Grafana page. But these are some of our worker nodes in our Kubernetes cluster. So we can see things like load, CPU, memory usage, and all those things. And we can visualize over all the different hosts And I'm actually just going to go ahead and take us there. So we can, filter off of all of these different hosts. If I want to see all the hosts in my cluster, I can change that. We can see that different ones are experiencing different amount of load, things like that. If we had different data sources, we can easily switch between them. And I want to emphasize here that Grafana, which is this tool right here, isn't just for Prometheus. This is another open source tool that's very popular in, I would say, pretty much the open source visualization community. In fact, they actually have an enterprise tool as well. But we can add sources like Prometheus, InfluxDB, Graphite. Another really neat thing here is you can actually add Elasticsearch, Jaeger, Datadog, Splunk, because I know my company uses Splunk and we're considering enterprise for that. Grafana basically acts as this unification tool in a sense. And there's so much custom, ability to customize things. Like for instance, this is our landing page. Whenever our developers go to any one of our clusters pages, they're directed here. Now I know there's a lot going on, but basically we provide different dashboards for different views that allow them to sort of drill down and get the information that they're looking for. So we'll kind of go back to that in a little bit, but one of the other things I really want to talk about is kind of what we can do to alert off of this data as well. So you know how to visualize it, and sort of the next natural thing you want to do is say, well, if this condition is happening, let's say one of our Kubernetes nodes exceeds 90% memory usage. We want to know about that. We can use AlertManager, which is almost always deployed with Prometheus, to do that. And so AlertManager is basically configured with YAML files for the most part. And we can configure different rules, alerts, different paths in which these alerts get sent. I can show an example right here. This right here, using the Prometheus operator, is a custom rule. So we saw before some of those queries that I had typed out. And again, I'm not going to try and explain all of PromQL here, but these are two different alerts, one called long response time and one called errors occurring. And they basically have a simple Prometheus query and an expression saying, for how long does this event have to occur for me to trigger an alert? I specify things like severity, title, annotations, things like that. There's a lot of templating language that you kind of get used to as you work with it. But then from there, I can send alerts to my Slack channel to say like, hey, we have this one endpoint, wait 5 is taking a longer than normal time to respond. In this case, anything over 5 seconds justifies that, and we can see we're just barely over it. But it's for the sake of showing that. Additionally, in fact, actually this is grammatically incorrect, has returned a value in error code. But it's just to go to show how you can create these SLA, SLO sort of level alerts very easily. And the really neat part here is if your development teams own the deployment YAML, they can also own their own alerts that live right alongside it, which is really cool to sort of have developers store their own alerts as code alongside their deployments. And my favorite thing about Prometheus and Grafana sort of paired together is the ability to customize things. There's almost endless opportunities to visualize things the way that you want them to be visualized. It just takes a little bit of time and effort on occasion. So we had this problem where we have a ton of different teams that are using the same cluster. So basically they either don't have access to our production cluster or things like that. So they don't always know if their applications were deployed correctly. So I built this dashboard to allow them to filter by team. So they could filter by any one of our teams that we have specified. And then they can see all the pods for their team. So we can see the application name, the pod name. If we wanted to click on the namespace, if I click this, it'll take me to a new dashboard just for that namespace. Same goes for the node. And we can see status like running and when it was created. So I already have one up here, which of course is not showing data. So this is a pod that I had already run earlier. And I could see if I were to click on basically any one of these pods, I can go ahead and do it right here too. And give it a moment. It will bring me to this view that I can view logs. I can see the CPU usage. For anyone who's ever set like resource requests and limits, I can visualize that here, which is actually really awesome. And it gives me sort of this high level view of what's going on in my container. And so this is a view that I've made for all of our pods. Obviously, if we're getting into more technology specific things, we can build even more detailed things that leverage application level metrics. And I can kind of show you an example of that real quick. So I don't know why it's not reporting now. Of course, it's the case of the demo, but right now I should be running a load test against my application. Oh boy, sorry about that. That'll go away. So basically, these endpoints are exactly what we're seeing. We're seeing that load test run against these. We're seeing basically the requests per second for these endpoints. If I want to go in here, I could see this graph for the total requests per minute. And if I go back in here, I could see the actual query that's responsible for that. So this query is one that we had actually typed up in Prometheus earlier. We can visualize that here. There's a lot of different ways to visualize it. So there's a lot to unpack here. So I can't really go into all of it, but these tools are so often used together that there's a lot of potential to, sort of use them together in that fashion. In fact, actually, I guess I just had to refresh it. So this is that load test that I started earlier. We could see all the activity going in. We talked about the histogram earlier, basically seeing the response time. If I pull this up, I can see this is the average response time of some of our applications. And we could see that the /wait5 takes just over 5 seconds. And so granted, this is very flat, but this is super useful for developers to like quickly see like, okay, we're seeing performance degradation on this API endpoint when the memory is here or the CPU usage is here. It's being able to draw conclusions by visualizing things in similar places over time. And we have this ability to go over a huge time range, and it just loads very quickly because of how the time series database is structured. You can set refresh rates, things like that, with sort of endless capability to link out to other places and template and just create this cohesive drill down environment that a lot of people look for developing. So let me just go back to my slides, make sure. I think I'm pretty much wrapping up here. Yep, no, that's it. At the end, that's kind of really what I wanted to talk about. Kind of get people excited, I think, about Prometheus, because I think it's a really cool piece of technology. And, alongside Grafana and some of the other tools like AlertManager, it has a lot of potential. So I'm going to go ahead and stop recording. Or actually, I guess I'll keep recording. And if anyone has questions and doesn't mind their question being recorded, even though I guess I'll probably just crop it out at the end. Actually, I'll stop recording. And with that,